All right, so here we have the graph of y equals f of x, that's the red one, and its image, and they're saying there has been a vertical and or horizontal stretch or compression done to it. We want to write the equation of that blue graph in terms of the function f. Now, when we did these questions with horizontal translations and vertical translations, it was really easy to see, oh, it's just been moved 2 to the left and 3 up. And you could do it quite quickly and quite easily. Once you're dealing with stretches, it's a little bit more difficult. So what we're going to do to help us figure it out is to look at how have the x's changed and how have the y's changed. So we'll start with the y's because y's always come up first, right, when we're going from left to right. So if we look at the vertical, distance between 2 points, we're going to pick points on our original graph and then pick corresponding points on our image graph. So I'm going to call this point down here A, because that's on our original graph, and this point up here B. And then on our blue graph, where does point A go? It goes right here, so I'm going to call that A prime. And where does point B go? It goes there to B prime. So now, when we're looking at our vertical distances, we'll first look on the original one. How far was it from A to B? Well, that would go from -8 up to 9. 17. And now when we look at A prime to B prime, what is it now? From -4 to 4.5, 8.5. What's changed? Can you see that it's been cut in half? When going from the original to the new one, that it's been cut in half? So in order to do that, your y values would have had to have been multiplied by half. We'll look at the same thing with our horizontal distances. If we look at A to B, we go from 2 to 3. That's only 1 unit. And then if we look at the image graph, how far is it from A prime to B prime? Now it's a half a unit. So what has happened? Wow, that's an ugly squiggle bracket. I'm sorry about that. The x has been multiplied also by 1/2. So now we know what happened. How would we write that in its equation? So the equation of the image graph, the blue graph, in terms of f, well, the y by 1/2, how does that show up in an equation? There'd be a 1/2 in front of the function. Then x by 1/2 happens inside the function. What would be inside the function to cause us to multiply x by 1/2? A 2. Because it always is the reciprocal when we're multiplying. Questions you can do are 5, 12, 13, and 14. And we're going to do one more example together before you get started on both those sets of examples. If you turn back, I think page 192, is that a blank open page for you? Yes? So if you turn to page 192 because you have open space, we're going to add one more example. We're going to get you to graph y equals 3 negative 1 over 2 x cubed. Because all of the examples we've done so far, they've always given you the starting graph. But you're going to have to do some where the starting graph isn't given to you. In that case, what you have to be able to recognize in the question is what is the parent graph of this one? What is this one related to? And it's going to be your x cubed. So off to the side, you're going to think of x cubed, and you're going to just quickly draw a sketch. I know what x cubed is. I know a couple of points on x cubed. So I know what my parent graph is. Then I can go through my equation, and now I have to decide what's inside the graph, what's inside the function, and what's outside of the function. So first of all, we'd run into this 3. What's that going to do? It's going to multiply our y by 3. Then we run into the negative 1/2. And that's going to multiply our x by the reciprocal, negative 2. So if we have that, we can take these 4 points and we can do both of those to all 4 of those points. So starting with negative 1, negative 1. And if you're going to make a mistake in mental math, somewhere it's going to happen in one of these, because you're going to do lots of little mental math. We need to multiply the y by 3, x by negative 2. So we get 4 new points. And we can start by labeling all of these. So we have 0, 0, 2, negative 3, negative 2, 3, and negative 4, 24. Estimate somewhere up there. As far as drawing the shape goes, we can think about what's happening if we describe each thing in words. First, if we look at the equation going from left to right, we're going to stretch it vertically. The negative is with the x, it's inside the function, it's going to affect the x values, that's going to flip it over the y-axis. And then we're going to stretch it horizontally. So if we can envision what that looks like, this will be our final graph. Can you see the flip over the y-axis? How that's different than our original graph? So sometimes we're going to be given an equation that we have to recognize the parent graph and be able to graph all those graphs that you did in part A on those color sheets that we did at the beginning of the year. And then you have to decipher, okay, inside this equation, what's changed? What affects it vertically? What affects it horizontally? What's inside the function? What's outside of the function?